Work it, make it, do it, make sense.
All right. Apologies for being slightly late. I'll dive straight into it. My name is Ian Sharp. I'm Data Science Lead at Oracle UK. And the theme to this session is Data Science is Easy. That's the title behind what we're sort of talking about today. So obviously the answer is it's not. So you can leave now. That's the giveaway. But the background to this is that I've been working in this space both at Oracle and previously with Microsoft for a number of years. And prior to that, I was in academia with SPSS. And really, I thought what we do today is just sort of explore the opportunities and the challenges that we're seeing right now with the term data science and how that's playing out in the market, and hopefully try and separate the reality with sort of some of the myths that are going on there. So hopefully sort of reality check, but also lots of excitement as well. So past, present, and future of what we're doing in this space. And the reality, before we get too excited about the whole thing, is that the reality is that for a lot of organizations, this is actually proving, and we talk about big data or datafication or data science, we really don't think it matters a lot. It's useful as branding exercise. It's about what we do with our data. We think there's value in there. We think there's belief in that data, that we can sort of change things in our organizations or however we interact with the world. But regardless of what we talk about, the premise, and I think we were at a super interesting point in the market, is that whilst the premise that we can extract value from our data and operationalize that into the real world is still there, and probably even more so, the reality is that organizations are finding it a lot harder than maybe they initially would. So 3 or 4 years ago, as this market first appeared as a nascent technology from the likes of Google and Yahoo, and the first generation of distributions around machine learning and open source started to emerge in the commercial world, certainly over here, then there was a lot of excitement about sort of standing up these sort of new technologies, and it was a lot of messing around with some stuff and a good opportunity to rebrand. The reality is that whilst that was the opportunity still hold true, organizations have struggled a lot more than maybe they initially thought, and maybe we could have foreseen this, but we'll explore that a little bit as to why that's happening. And the reality is that it's hard in certain ways that perhaps aren't really the sort of thing we would have foreseen. So we talk about the idea of good hard, bad hard, and we'll talk about a little bit of ugly hard later on. But the good hard is obviously your data scientists, your knowledge workers, sweating your information assets, finding knowledge from them, and then operationalizing the value, putting it into the mainstream. The bad hard is actually getting to that position in the first place. And what we're seeing, which is really frustrating for people like me, is that a lot of these projects are starting to fail. So a big retailer that we're talking about, we partner with Cloudera in this sort of space, and a big retailer who do a lot of sort of digital marketing and talk about a lot of these things, these events. They've laid off all their data scientists, which is hugely annoying because it's too hard to get the data into the system in the first place. I'm working with a big a pharmaceutical company, and they've got lots of bright data scientists, and they're using scikit-learn and pandas and all the things that we get very excited about, and we sit and talk to them, and we say, well, what are you doing with it? And they say, well, it's taken 12 months to get any reports out of the system in the first place, because it's really hard to make a lot of this stuff work together. And similarly, a big telco we work with, they're switching off all their open source, and this is not an anti-open source message at all, it's very much the opposite. But they're switching off all their sort of build your own open source on Amazon, because the CTO just sees huge costs. People are spinning up instances and not really seeing any value. And so this is a real massive problem. So we are seeing sort of opportunities around this, because actually there's a huge benefit to be had from doing some stuff around this. So what we really sort of talk about is taking away those kind of bad hards, which is actually getting the things to work in the first place, getting all the stuff to connect in the first place, getting it to scale, all the boring hard. We kind of think there's value in doing that. That's the kind of stuff that we come in and do in this sort of space. So leave your guys with the good hard, which is actually sweating your information assets. How many of you would call yourself data scientists, have used packages like Jupyter and the things? So a smashing of you guys in there. Okay, so look, I mean, absolutely, so I use a package called Anaconda, which is a framework for managing your your Python packages for machine learning. And for kicks and giggles, I decided to install Anaconda version 3 as opposed to Anaconda version 2 on the Big Data Lite image that we had. Not only did all the applications that I wanted to work with it, all my Jupyter notebooks and all my Python packages stopped working, but everything that used PySpark, Spark in general, stopped working because there was a conflict between my Spark Avro files. There was a version jar constraint that was out of sync. Not only that, but I couldn't deinstall anything because it kept on leaving a whole bunch of residue around the system. And so basically everything stopped working on my machine and I had to rebuild. So it's really easy to be stupid like me and get it wrong. So the whole thing that we're sort of trying to do is just put a bit of pragmatism there and say, well, look, we'll manage the installs, we'll make sure it all works together to leave you the good stuff. So that's really sort of messages. And you know, it's scary. And so what I thought I'd do is I'd show a couple of pipelines, some design patterns that we're seeing that hopefully illustrate the different approaches to doing this. And also share some stories, because which is far more interesting, hopefully, than hearing technology vendors talking about themselves. So I wanted to share with some examples of things that we think our customers are doing that are really kind of cool. So the first one, and who have gone through this journey, probably more importantly. So the first one I want to talk about is the Perform Group. I don't know how many of you guys come across them. So they are a big sports digital media provider. So in the US, they manage the sports franchises for American football, for baseball, for basketball. In Europe, they're probably best known for football, so and rugby. So they manage the Opta statistics. And effectively, they have two streams of data. They have what's called event data. So they have a bunch of kids sitting with Xbox controllers, which is my son's dream job, watching football matches, and they're sitting there tapping away, and they're capturing this information in real time. And it's everything from really trivial stuff like a foul throw or Wenger remonstrating with the ref, right through to the goals and the big deals in the matches. Okay, and they provide this through to the tier one broadcasters, Sky, ESPN, BT, BBC, all consume this information in game. They provide it to the broadsheets, the Times, the Guardian, etc., etc. And they also provide it to the clubs themselves. So the football clubs, ironically, are becoming increasingly statistically obsessed. To the extent that there's this concept of the golden triangle. Have you heard about this before? So any of you follow football? Okay, so the idea behind the golden triangle is that the pitch gets broken into thirds, and the attacking third is the most dangerous zone. And they have this concept of the golden triangle, which is the supporting, holding midfielder behind the two attacking guys, passing into a space between these two fellas. And they call it the golden triangle because they know that the successful passes between these two angles results in goals most often. So there's a guy who plays for Man City called David Silva, who's somehow a genius at Euclidean geometry because his passing angles are better than anybody else in this sort of whole space. So it is kind of absurd. You know, they talk about, but it gives you an indication as to how statsy sports companies are becoming. So massive opportunity around this whole area. These guys talk about the fact that last season, Leicester City did an awful lot of analytics. Aston Villa did very little. One of them won the championship. One of them got relegated. I'll leave you to join the dots as to which one was which, in case. But nevertheless, a huge opportunity there. The other side of their business, which was probably even more exciting, is the idea of taking real-time Internet of Things data. And that's what we're going to be focusing on in our demonstration as we go through. So I've got plenty of time. And so this is basically 23 high-def cameras capturing 25 frame per second information around every single football match, so La Liga in Spain, the Premiership, and so on and so forth. And there is a massive opportunity for this organisation to merge this information in real time. Huge opportunity. It's worth millions and millions of pounds to them. So, for example, the broadcasters want to know when a goal scores, where every single player is on the pitch. Clubs are obsessed in terms of looking at player under pressure, for example. So which of their strikers is best under pressure? And they define pressure as having two opposing players within a radius of 6 feet when the goal happens. But this is a really hard problem to solve because all we've got is we've got an X, Y coordinate of every player, and we've got an X, Y, Z coordinate of where the ball is. That's all we've got, and that's all we know. So for example, when we're trying to match up these two events data, and this amazing little guy here, Messi, does what's called a nutmeg, which is when he nudges the ball through somebody's legs and he sprints around the other side. For a moment in time, he's actually lost control of the ball. It's close to somebody else. So it's quite hard for us to work out what's going on here. So we did a whole bunch of sort of Sokotoa type SQL. So I had logic around that and some read-ahead SQL to make that happen. But actually, there's a whole bunch of error built into this. So for example, cameras fail. So some of these cameras fail sometimes. players warming up is a nightmare because all the pitches are different sizes. So you've got two guys hurtling up and down in bibs. We kind of know who they are, but to our feed, it's just these two little sort of dots working around there. Corners are a nightmare because all players hurtle into the sort of box at the same time, and so it's really hard to pick out who these individuals are. So from one perspective, it's a massive opportunity. It's worth millions to them in real time if they get it right. If they get it wrong and they start spewing garbage to Sky, then their whole brand equity is completely destroyed, right? Because that's what they're based on. It's all about quality of data. So the solution is actually effectively a mix of some trigonometry, some machine learning. So we run some single class support vector machine anomaly detections with Gaussian kernels, so some cool little algorithms around that in real time to sort of spot outlier behavior and faults. But actually what it really is a real-time risk modeling solution that's happening in this sort of context. So it's when we have these streams of data coming in real time, what is actually happening? Is it real? Is what we're seeing what's going on? If it's not, and the probability of that being high, then we can intervene. We can look at that. We can pull it from the stream, etc., etc. So although it's quite specific, sports media is quite specific. What we're really interested in doing, and what's cool about these guys, is that we can cross-pollinate the ideas into other sections. They've effectively had every bit of open source commodity stuff. So we do use open source for this. So some is using Scala, some of it's using. So we're actually doing part of the thing, which is quite interesting, is they do real-time gaming. So they have a bunch of data scientists working in Poland. They're building Scala algorithms in real time to profile corner situations and looking at the odds in terms of what's going to happen for bookmakers. So it's pretty leading edge as far as I can tell in terms of the applications we come across. But the reason they invested in an Oracle platform is because we knitted it all together, so they had to get this thing up and running by the start of the season. So really interesting company in terms of what they're doing. The other thing, oh my God. So the other thing that's interesting about them from a cultural point of view is they're all the data scientists. They have lots of bright young data scientists coming out of New York, and they get poached by the baseball teams out there. When they bring them over here, they get poached by the football teams because there's so much money involved in academies. So Chelsea and Man City, who I'm sure you all aware if you don't follow football, are massively rich corporations. Interestingly enough, what they're concerned with is not the value of the players that they're going to buy, because they don't really care about that. They're concerned with the resale value of the academy players who will never play for those teams, but are getting the sort of stamp of approval to go through the systems. So there's huge amounts of money, so it's hard for them to sort of hang on to these sort of guys from a data science perspective. One of the ways they can do it, though, is by operating a self-service data science paradigm whereby we can operationalize the value of R in a very simple way. Another one I want to sort of talk about here is CERN. So CERN are great, and it's real big data. It's a petabyte of data a second. It's real data science, so they're all double PhDs, and they're going to leave every 6 months anyway. But the cool thing about this is that actually it's quite universal. And one of the dangers with data science is it becomes, and this is my pet peeve about it, is it can become massively esoteric and exclusive for all the kind of wrong reasons. So guys like me can stand here and talk about building pandas on Jupiters and binarizers in the Skykit, and some people are going, oh yeah, that's great, and 90% of the room will go, what on earth are you talking about? And that's traditionally maybe a reason why, because of the advent of the sort of open source startup cultures that didn't have tools. That's why it was the case. But what's really encouraging about these, which is some of the most brightest, most innovative data scientists, is they're actually using GUI tools for certain aspects of that process. So for the basic exploratory data analysis on the Hive tables, they're not going to write binarizers from scratch. They're going to use a UI for that, and they're going to pass that data to the machine learning stuff from the ensemble modeling from scikit-learn or TensorFlow or whatever else. But it's much more pragmatic. So the danger is that actually people just focus on writing code as being a realm of data science. The reality is absolutely not. There is no reason why that should still be the case. The other really interesting thing about data science is that people sort of talk about what a data scientist is, and there's a great company in the UK who are around in maths way before data scientists. So I was originally a sort of mathematician before I grew a beard and hoped for a pay rise by becoming a data scientist, and still hasn't happened. And these guys come from that background, and they do a thing about what kind of data scientist are you? And you go into their website. They're called Manga, by the way. Look them up. They're great. and you enter a bunch of questions, and what it comes out with is one of those spider webs of attributes. And interestingly enough, there are 5 or 6 different attributes to what data science is. Sure, there's the modeler stuff, which is the statsy thing that everybody thinks it is, but it's also about sort of data wrangling, it's also about coding, it's also about visualizing, it's also about communicating. And the reality is that, you know, the unicorn is the guy that can do them all. Nobody can do all that sort of stuff. So really, in terms of the entrance point to data science, you know, if people are coming from coding, from visualization, it's much more about the sort of spirit, and if that's not too woolly, the passion about data, the passion about getting involved. So we're looking to try and make it much more inclusive, and I think they're a great poster child for that. Thanks, guys. And finally, one before I get into the demonstrations, again, I mean, home base here, right, guys? I don't know much about wargaming. But this is really encouraging because actually a lot of the sort of use cases, and this comes down to the original challenge that we talked about in terms of why people are, on certain cases, switching off data science and big data. And the problem is that as it moves from innovation to mainstream, you're going to start to get the man looking for value. You know, it's great messing around with this kind of stuff, but where's the value in this? Okay, where's the value? And as it moves into mainstream, it will get those sort of challenges. And so so it's great to mess around with this stuff, but it's also sort of good to kind of find a metric around, you know, how much is this worth to the organization in any ways. So this is really good because it's actually quite traditional CRM. It's just vast volumes of data. So these guys, Wargaming, 300 billion events per day. So it's a personalization kind of problem. You know, but the bottom line is that it's delivering a tailored message and an experience and an interaction that's much more one-on-one, and there's a metric around this. You know, one of the big areas, my first project, is anybody from Amazon? No, okay, good. So my first project when I joined Oracle, Amazon were a big friend of ours at the time, so they were a big reference for warehousing back around the turn of the century, and you know, they were the first petabyte. They introduced rack, they introduced partitioning, so they were great. And so whenever we brought out a new bit of technology, somebody would say, "Who else is using it?" We'd go, "Amazon." So it was really good. Then we introduced them to our first generation of personalization engines. So this is when we started to move beyond collaborative filtering into the realms of statistical functions like transactional naive Bayes and predictive association. So it started getting a little bit more Statsian involved, and yeah, it went a little bit sour. But nevertheless, the technology in this whole space was really, really promising for personalization. We could actually start to build better models because we could get more statistical oomph behind it. And that was 15 years ago. And then we went into like the Discovery Channel, and we started to profile those guys in terms of the sort of people who watched the Discovery Channel. So they were kind of interested in the idea that people were interested in things other than serial killers and sharks who watched the who watched the Discovery Channel. They found out they weren't actually. It was a kind of an awkward conversation. But nevertheless, you know, that whole experience was really interesting. And my personal bugbear in this whole thing is actually, I think, personalization hasn't really moved on very much in the past 15 years. And this is the big sweet spot. You know, the idea that we want content that is really down to us and really sort of relates to us as individuals. So digital marketing agencies talk a lot about grey sheep. This concept of the idea of grey sheep is your tastes are too outlier for our algorithms, our Cox proportional hazards, our machine learning algorithms to identify. Which, of course, the reality is that everybody's a grey sheep, right? It's just that the challenge is the data's so vast, the algorithms are quite CPU intensive because it's pretty much lots of recursal table scans. So effectively, that's why we're left with this, you know, equivalent of banter, which is saying the most idiotic thing really, really quickly, that forms the basis of most social interactions and personalization. So nevertheless, but the point here, and the salvation here, hopefully, or the guidance here is that as processing becomes more powerful, as the algorithms get more sophisticated, the premise is that we can start to use more sort of beefy techniques to find better inference and relationships in that data. And we're just starting to explore the likes of machine learning and deep learning algorithms in this sort of space. So we're looking at people's preferences for music in terms of emotional response to music and profiling that. And seeing what that impact has in terms of content personalization. So the idea is that the more we use data, that, you know, we can get better at serving those things. And this is a great example because there's a big metric behind it. So just some examples that we're sort of playing in this sort of space. But all organizations that have gone through the curve of trying to build it themselves, trying to stand all the stuff up themselves, and and struggling. And we think there's value in having an end-to-end platform where we take away that pain that leaves you with the opportunity to sort of really innovate and find cool stuff in your data. That's what we care about. Okay. Any questions at this stage? Good. Right, I'm going to sort of shift gear at this point. I'm just going to take you through a demonstration here in terms of sort of some of the things that we're seeing really resonating at the moment and some of the common areas that we see a lot of interest in. And we have what's called a series of analytical design patterns. And so we create these for different methodologies and for different work streams. And so this is one that's fairly universal at the moment. So it's an Internet of Things prediction problem. So the idea here is that we have real-time internet data. It's based on a financial services application. We're going to apply a machine learning algorithm to this in real time, and we're going to apply it into a stream. Okay, so we'll take you through that process as a data science methodology, and we'll compare the different ways to do this. Oops. Okay. So, yeah, I should say. So typically, my entrance point to big data would be an Hadoop environment, which we would use. And typically, I might start off with something like Hive, for example. So Hive is, I'm sure many of you know, it's a way of querying against, it's a way of sort of constructing metadata over and above Hadoop data sources. So we can query against this, but it's not necessarily the easiest way for a non-specialist to work on, and it's not necessarily the easiest way to share data. So going back to the Perform group, one of the lines of business that they work on is providing they effectively build themselves for gaming companies as the Netflix for sport. So they provide real-time streaming to the William Hill, to the Ladbrokes, etc., and they're paid a lot of money for this kind of thing. But when Ladbrokes would come along to them and say, how many people subscribe to this service, it would take them 15 days because there's one guy writing pig Latin scripts to do this whole thing, which is really kind of scary because if that guy disappears, they're running their business on it. So we kind of, so again, one of the sort of constraints we're sort of seeing is try and move this into much more of a mainstream way of doing this. So actually, rather than starting from a pig Latin script or a Hive environment, wouldn't it be nice to use what people like CERN are doing and create a GUI tool for querying that data? So my starting point in this particular case is something called Big Data Discovery. It's a visualization tool to go directly against my underlying data sets, hopefully. I might go in a different way. Let's try it in here. Sorry, bear with me, guys. I'm going to just bring up this interface in a different way. Tunneling, huh? Okay, so effectively the way this technology is designed, and I said Sony use an awful lot of this, is that it's designed to provide a very shareable environment for our data scientists to start to query data. So rather than having you code everything from scratch, they can come in here, they can explore their Hive tables, they can pull it into a Spark environment and query that. So, oops, that's a different project. So, wait a second. I'm going to show a financial crime one. Yep, we've got a Formula One demo that does a similar sort of thing. So here, for example, I've got a fairly simple view of my data. I've got some sort of recency frequency data. I've got some latency. So I've got some stuff that's pulled from a relational source, some stuff that's pulled from my sensors, and I've got the thing that I want to model here, which is a sort of type of financial crime. And we're categorizing it in a very, very simple way. So it's a machine learning problem, so it's high risk, low risk, medium risk. So it's a fairly sort of trite example in terms of how this works. But the idea is that from a data science point of view, rather than sort of writing code at this perspective, I can start to query this, I can drill into any of these components, I can look at the relationships in my data, so I can look at the distributions, the whisker plots, the box plots, all the sort of things that, as a data scientist, would be really useful from an exploratory point of view to understand what's going on in my data, what the distributions look like, how I can query it, and so on and so forth. So I can come in here and I can look at the credit rate, and I can slice and dice on that. So prior to these kind of technologies existing, it's very, very hard for us to sort of share and collaborate on this kind of work in the data science arena. And going back to the point of view we said earlier on about there being no single sort of person that can do it all, the value of data science very often sort of stayed in the heads of individuals and didn't really get into the mainstream. So we're sort of talking about a much more collaborative way of doing this. We can also apply a whole series of transformations on this data. We can publish as Groovy scripts. So again, it's much more about sort of self-service. It's much more about making that whole process much easier for the data scientists to use. Now, struggling a bit. This is all running on a VM we have, so it's available for you to play with, but the point behind it is that it's got an entire Cloudera distribution with all the sort of bits configured for you and ready to go, so it's pretty self-contained. So in this case, rather than having to sort of write code to restructure my data, it will recognize the sort of types of fields I've got. So if I've got a string variable in here, then it'll allow me to restructure my data, it'll allow me to create Groovy scripts and so on and so forth in a very sort of GUI way. And we can visualize stuff in here too. So in this case, I might want to look at a correlation chart. So it's a bit of exploratory data analysis in here, and I might look at the correlations between the different attributes I've got in my data set and the thing I'm looking to model, which is a financial crime risk on this particular transaction. So we can come in, we can visualize those too. Let me just kill that for a second. Okay, I'll come back to that in a second. So we'd work through this process. Now, here's the nub. Here's the nub. As we go through the methodology, I'm kind of reaching the end of what I can do with GUI tools. So sooner or later, I'm going to have to get my hands dirty in terms of writing some code. Now, the coding world's changed massively, and the ML world's changed massively in the past few years. So 5-10 years ago, just as relational data and Oracle and the big vendors was the only way you could manage data, and we all know that's no longer the case. Similarly, there were very few ways for us to do analytics. R didn't really exist, Python didn't exist, Scala certainly didn't exist. So the choice was to go to sort of the big kind of network computing vendors, and that's hugely changed in the past sort of 5 years, and that's been massively liberating. So 5-10 years ago, you'd have an algorithm argument about somebody. So if you were talking to a media guy and he was doing market attribution, and you'd get into conversation about an architecture and making things cross, and he goes, well, have you got Cox proportional hazard? And you may or you may not. If you didn't have it, you're in not a very comfortable place. Now, with the advent of open source, you've got 5 or 6 different flavors of that proportional hazard. You've got 7 different ways of doing it. So it becomes much more about the architecture and, more importantly, the kind of people you've got in the organization and how to make that operational. So in this case, I use Jupyter an awful lot. So Jupyter is an open source Apache notebook. It comes from academia, so it's a really good way for us to sort of configure and share our analytics. So let me just... So this is Jupyter. How many of you come across Jupyter? A few of you? Okay, very, very good. So yeah, so there's a couple of flavors here. So Jupyter, Zeppelin is another one, but they're really, really cool, and it's just a really nice, elegant way of creating and running code. So these originally came from the Python notebooks, the iNotebooks, and the idea is that you have these context cells. You can run iteratively your code. You can have Markdown in there. You can have drill outs to sort of different sessions, etc., and different content. So people are creating whole presentations with this framework. Jupyter Jupyter's kind of similar to that, except it's been extended to cover code from Jupyter.js, Python, and R, hence Jupyter. You'll see it in the name. But this is really cool. So I use this. So in this particular case, I did some machine learning. I built some predictive algorithms using a library called scikit-learn, which is an open source library. Love it. It's really cool. So if any of you come across things like the Netflix prize, then it uses ensemble models, which is like a superset of classifying things, and they've run it for the past few years, and it's all open source, and people contribute to that. And so here, for example, I'm using Panda packages, and I'm doing some sort of summary statistics, so I can come in here, I can run correlation coefficients. So, for example, so one of the things I'd be interested in at this particular point is what's called a whole bunch of exploratory data and analytical functions. So, for example, I'm using a pandas correlation method here, a Pearson method. What this is looking to do is identify correlations between variables. So that's really important when I build my models later on. And so I may know that my series is monotonic, so therefore I'm going to use a Pearson. But actually, I may look at my distribution and think it's linear. So I might want to go to the default Spearman's in there. So I can come in, I can rewrite this, I can simply recode that, so I can take the method back to default, and automatically all the code will change behind this. So it's a really cool way for us to be able to sort of share the logic behind what we're doing. Great, but it's all coding. Now, one of the coolest things that we've managed to do in this whole framework is also incredibly boring, but it's very, very cool to the people that care. And this is called a BDD binding, so Python binding to this. So this little line here, the Python execution shell, pretty sexy for data scientists, so we get pretty hot under the collar. But that's hugely useful, because what that means is that we can take all the output from our BDD environment, all the restructuring, all the groovy scripts. We haven't had to bother with binarizers and writing graphs to do this. And we can apply them as collection keys into this framework here. So that's really, really cool, because previously, it's really hard to move. There is no single tool for everything, right? We know that. But it's really, really hard to move things from one environment to another. So it's really kind of hard to move it from a data prep environment, an ETL environment, into your coding environment, into something else. That's really hard. And so often people have ended up with doing things suboptimally in one tool, because it's just too bleeding hard to do it all across the two. So we've really been focused in working with organizations to try and make this part of the process and accelerate that whole learning thing. So use GUIs for the good stuff at the front end, and then pass it into here, so I can then build my machine learning models in this context. And in this case, you could use Oracle's technologies. I've used a bunch of stuff in here. So I've used, let me see. I won't bore you with the details of this. So I used some ensemble models with gradient boosting in there, I think. And there's a whole bunch of statistical fits on that. And then I came up and I tested those models, and we've got predictions. So I run my sort of standard code. But the cool thing about this is that because it's running on a fairly beefy node, so we tend to have big beefy nodes on our Cloudera distribution, it means that we can sort of try and get around some of the issues of scaling, of multi-threading and parallelizing Python from first principles. So, for example, if you guys are looking at TensorFlow, great. So TensorFlow is the Google DeepMind project for deep learning. I'll talk a bit about that later on. But if you're using those libraries, great, fantastic. Just plug it in here, and it's just going to run quicker. So that whole kind of proprietary algorithm stuff is kind of fading away. We have a bunch of them, but we don't really care if you use them or not. It's much more about plumbing it into this environment. So it's a huge sort of change and making that sort of much more practical. Might do some visualization at this particular point, et cetera, and we deploy that into the process. So imagine the scenario. I've gone through a very, very quick view. I've explored my data. I've done some summary data analysis. I've done the clever modeling to make predictions on whether these transactions are potentially fraudulent or not. That I'd then like to sync it into a stream. So I'd then like to sort of have that as an operational data stream. And if you've visited our stand, so I'm not going to show this as a live demo today, but the final part of that process is that here we can pull that real-time learning into a streams analytics technology. So this is based on complex event processing, and here we've got these what's called zones of interest or polygons of interest in certain locations. And against this, we can feed in our real-time learning. So we've got all the sort of information around that, but we've got a credit card number, the things that are happening in real time, and we've got a real-time score based on the machine learning. Now, here's the point behind this. What we've really done is taken an ingress of streams data, we've augmented it with some relational data, we've put it into a hub, we've made a real-time REST API call to a machine learning algorithm that makes a prediction, and then we've sunk it into a streams analytics hub. Now here's the thing, we have choices on how you do this. By the way, you could do this both in our infrastructure. This is absolutely not about saying, ooh, you're going to do this way because this is what Oracle do. But you have choices. So what you could do is you could use something you could use something from Storm for managing the hub. You could have an ingestion semantic language from the likes of Kafka. You could then take something else from Zookeeper to manage the resilience. You could then have something else managing the whole process. You could then maybe use some machine learning, a separate tool, This becomes really, really hard. This becomes really hard to sort of manage. Or in this case, I've just used a sort of couple of web services. Now, this is absolutely not to say that every single thing can be done in this way, but it does sort of illustrate one of the problems is that to try and get away from making all this sort of stuff working in the first place to getting the value is sort of one of the sort of key messages that we're seeing as resonating in this sort of space. Or, you know, I've just used a couple of web services, cloud services, and a desktop tool for visualizing that. So what we try and tie it into is the idea of design patterns, and so these are pretty much the same as we'd see across any of these sort of processes from a data ingestion point. You know, there are challenges around each of these things. So it's kind of hard to get a lot of these things to join together. You know, particularly as we move into the polyglot world and we're consuming new sources of data other than relational and streams data, it becomes quite difficult. We have this process, this methodology of wrangling our data, figuring out what's going on, building the models, iterating through that. And then we've got the process of actually operationalizing the value into the front end. So, for example, I don't know if anybody who's tried to deploy sort of Scala packages or Python packages or Spark packages and managing that whole kind of Kubernetes sort of Dockerized frameworks in the past. That's really hard, right, guys? That's really, really tricky to do. We talked about 300 customers last year. 298 of them really were saying, this is a big problem for us. So there is help on hand. I mean, I know that Cloudera, our big data science partner in this space, have a solution coming up, which is quite exciting. But 298 out of 300 people said, this is a big problem. This is a big challenge for us moving forward. I don't know about the other two. They're either geniuses or they're mad or they were lying. But nevertheless, you know, the point is, though, that as we move from experimentation, which is really cool, really, really exciting, we're now starting to get to the point of people saying, right, come on, guys, let's get serious about this. Where is the value to this? And looking at some of the sort of more pragmatic things around scalability, around governance, around security, around all that sort of boring stuff, actually does become really important. So I've got 10 minutes left. I just want to wrap up with a little bit of a look. You know, we've explained where we've come from in this analytics space. We've hopefully highlighted where we're at, what the current challenges are. I just want to talk a little bit about the futures of this. It's kind of the present, but it's also the future, really, in terms of where we're going with this. And I am hugely humbled to be Oracle's representative on the Data Ethics Committee for Oxford University. So this is across company initiative, so Microsoft are there, Oracle are there, Facebook, Google, blah, IBM, etc., etc. And front and center to every single conversation for data ethics is machine learning and cognitive services, okay? So the whole advent of deep learning and how that works. I used to work at Microsoft, and my previous CEO Satya Nadella talks about the democratization of AI and the advent of the empathic robot. And certainly every single company is aware of this. So what I thought I'd do is just sort of give an update in terms of sort of the kind of thinking that's going on in that space, and also a reality in terms of where we see the technology at the moment, because although it's hugely exciting, you know, some of the premise isn't quite there yet. We'll sort of highlight the good stuff, the real stuff, and maybe the sci-fi stuff. Because the reality is that if we're looking at this as a journey, that's kind of Neptune, and a lot of us are still trying to get out of our shed to get to Mars. maybe, or at the end of the garden. So it's important to know that, but the challenge with data science and all this big data, and it's a good and bad thing, right? It's great that people talk about this. People didn't, Newsweek and the Times didn't talk about big data or didn't talk about BI or stats or anything like that. So this has grabbed the attention of the press, but with that comes the challenge of actually managing expectations. So hopefully just a few minutes in terms of some of the things that we're sort of seeing as really, really good use cases, and the things that far brighter people than I am at Oxford University are saying about how we sort of move forward with the ethics of these sort of technologies. Okay, I always put this up, right? Okay, couple of things really. The first thing to say is that there's certain technology areas that are really, really good. So I think that video recognition is some way behind, and facial recognition is some way behind sound recognition. Okay, so that's the first thing. For some reason, it's certainly in the mainstream, certainly in the public area. So the use of those technologies is kind of basic. So one of the things that, but audio processing seems to be much better. So one of the things that we're doing is we're working with a big Formula One team, and what they're interested in doing is they have open chat on the races. Everybody's sort of yakking away in their different languages, and what the different teams have is a bunch of translators listening into these open channels because they want to hear what Ferrari are saying, or Honda are saying, or Williams are saying, because they can use that for tactical advantage. And the process for that is really manual. They have guys sitting there listening, typing it in, transcribing it through. So wouldn't it be great if we could identify the individual, the person who's actually speaking, what they're saying, and feed that back in real time as a stream? And there's quite a few components to that. The first one is spectral frequency analysis. So what we do is we apply a spectral frequency graph. We strip the voice from the background noise. So we can do that. There's really cool open source technologies like Librosa out there that I play around with a lot, which are really good for that. We can then start to identify the speaker. So a human voice is as unique as a fingerprint if you can get that recognition. So your thorax, the size of your echo chamber, your lips, et cetera, combined together can become as unique as your fingerprint or your heartbeat. We then combine that with actually what that individual is saying and strip that noise back and feed it back into real time. So there's 3 or 4 different components. That's really quite difficult to do, especially as people are sort of talking at the same time. So you've got to be able to sort of strip out those sort of frequency ranges. But that's pretty good, and we're actually getting there. To be fair to Microsoft as well, at my time, one of Microsoft's applications is drive-through in McDonald's. And so there's some guy it sounds like Detroit on a Saturday evening. It's really noisy. I listened to this WAV file. I was like, ugh, couldn't barely hear what was going on. Never mind what he was saying. But what they do is they strip the voice in real time. They feed it into a human who's working on a till, and he figures out what the order is. And I think that's the key in terms of the use of these kind of technologies. It's things that are going to augment human interactions, so make human interactions better rather than replace them. They're kind of ethical. Nobody's going to sit there and say, well, I don't really like that. That's a bit creepy. The other side of the thing is that we see the rise of face recognition and emotion recognition. And the problem with a lot of that is that it's really kind of surveillance capitalism, right? So you'll be walking into a shop, and whether you're frowning at a banana, somebody will pop out from somebody and say, you don't like look at a banana. People don't really like that. There's not really much value to the individual. So it's about sort of the value corridor, if you like, and staying within the lines. Not too much value to the customer because otherwise we don't make any money from it, and not too much value to the business because they're being exploited. So stay in that corridor is the sort of cool thing in this whole sort of space. I think there's a long way to go with face recognition and emotion recognition. We've done some cool stuff in China with looking at smoke. So effectively the way these things work is that people talk about deep learning. You heard that expression? Deep learning is really just a superset of neural networks, okay? So they're like clever multi-layer perceptrons. They're just working on different data sets. That's kind of really how they operate. So in this case, with face recognition and motion recognition, what it's going to do is look at pixel densities around certain areas in a face. It's going to recognize that a part of your face is your features. It's then going to look at distances between those using a multi-layer perceptron and plot similarities with other people. So Microsoft have this application called celebslikeme.com, and effectively you feed in your photograph. I'm the old guy on the right there, and it profiles you with the celebrity that you most look like. We're doing a cool one in China, actually, which is looking at smoke. So we can identify the RPG values of smoke and then look for smoke in public places. So that's quite cool. This is the person I most look like, according to Microsoft, from his algorithms. I couldn't help but feeling a little wounded by this. But but you can see how it works. But you can also see that actually what's really missing is context to a lot of this sort of stuff. You know, the Pepper Project, they talk about the idea that there are, I don't know, in about 10 years' time, machines will probably be able to make 1 billion neural connections. You know, and synapses. The human brain has 100,000 billion. So there's some way to go before these sort of computers will take over the world. I had a conversation with my friend, obviously, and we go about sentient machines and thinking robots. And there's obviously, you know, lots of literature around this. And we started off going, isn't that terrible? And then, you know, 3 beers in on a Saturday night, we thought it would be kind of cool to be subjugated by robots at the end of the day. But nevertheless, there's some way to go yet, guys. But I think the serious point in this whole thing is that there are some super, really interesting applications out there. I think voice is ahead of speech at the moment. It's coming. We need to sort of provision for these things, but really sort of, you know, find the good cases and the ethical cases. There's plenty out there. Okay. Oh yeah, and then in the interest, I profiled a genuinely handsome movie star here, and this is who Leonardo DiCaprio looks like. I think it's sort of like, you know, saying if you've gone on a sort of meth binge for the next 5 years, that's what you. A warning from history. Anyway. Guys, hopefully that's useful. Apologies, it's a fairly quick run through. We're running out of time. Just 2 sort of real takeaways. If you're finding it hard, don't worry. Everybody else is. But there is help on hand. There is help on hand. There are ways forward with this. And you know what? It's a super exciting time, right? Because this is front and center. And what else are we going to be doing? It's amazing. All right. Thanks, guys. Cheers.